Greetings, folks. This is Scott with the Game Audio Institute, and we are in my, I'm doing the Constellation thing still. And today's experiment is going to be looking at Chunity. That is the plugin that Chuck has provided, the DSP programming language Chuck has provided in order to be able to run Chuck scripts and do Chuck events and things like that inside Unity. I am a complete newbie to Chuck. I don't know anything about it whatsoever. Never done anything in it, not even making a tone so far. The package is available on the Asset Store. You can just type CHUNITY to install it. I'm using Unity 2022.2, and I'm building for Android, and there was an error in one of the scripts. Now, I haven't done any building at all so far, but at this point in time, after throwing away the script that had the errors, it was just an example script. It wasn't like of absolutely vital importance or anything like that, not like a core feature or anything like that. Once I threw that script away, it did compile and everything is cool. And I'm able to go through most of the demos pretty well. There's oftentimes when you have these kinds of things, they might be using the old input system, so certain things might not be working until you enable things. It's a little bit tricky to some extent, but at least some of those demos will likely work for you. There's a lot of demos, so I'll let you know kind of what's going on, and we'll just go straight into it. And I'm also going to show you a little bit more about how I hack through code I've never seen before, basically, in order to be able to figure out what it is that I want to do. Okay, so we will go check that out. So this is just a Chunity demo, essentially, script. It's once you install Chunity, it's here. There's a couple of things you need to do to set things up to get things to work. So Chunity is using Unity's own audio system to generate audio. To do so, it often has to use the streaming assets folder. So it actually created its own streaming assets folder you have to rename and put this example Chuck script and impact sound effect so that the demos will work. And when you install things, basically you've got this Chunity folder. It gives you some stuff about the information for installing, which is useful. That's like I said, that it has this streaming folder thing. You can just drag it in here. You should also not change the name of these directories since they are special folders. And inside here, there's actually this plugins, resources, and editor. The thing that's I basically started with is a simple demo that all it does is it plays a beep sound and rotates a cube in a particular point. Okay, rotates a particular cube. So, and that uses a script in order to be able to make all that sort of stuff work. So I'll just give you the demo. So the Chunity examples are here. There's a bunch of different examples. You go through them all. Oh, I should say where they are actually. They're under here, Chunity, and then scenes. And then if you double click that, Chunity examples. And there's callback tests in iOS, Android. I have not tried any of the iOS, Android examples so far. Possible they might be using things like, the gyroscope on the phone or something like that. So it might not necessarily be a relevant demo for my purposes specifically. And we might not necessarily try this in VR, at least to begin with. I'm just trying to see if it'll work in the editor for now. So the goal for today is basically what we want to do is be able to essentially create a row. This is exactly like what we're going to be doing in Unreal, essentially, right? So create a row of objects, have it look to see if the renderer is on those objects, and then if the renderer is on, then play a note. And if not, don't play a note. Okay, that's basically it. All right, so I've got this Chunity examples on. If you turn on, it will give you the game scene. It's a pretty basic thing. There's some stuff here. Run code demo. Let's see what happens. And we will go here and say, that plays a sound, I believe. It looks like it did. So, and as you can see, what happens is that it rotates that cube just a tiny little bit every single time you press the space bar. Now, what happens is you can also then press enter. You can see my videos kind of blocking it off, but anyway. So just press enter to cycle between Chunity examples. Some of these are working, some of these are not. I had to do some sneaky stuff to get some of them to work, but this one is a time advancer demo. And this is the one where we're actually going to be using. So what happens is, take a look at this. See, if we move the mouse, it slows down. And if we go this way, it speeds up. If you can see there, it's actually rotating the cube every tiny little bit. So in other words, it's a time advancer. It's actually like, doing that. Okay, so let's take a look at the script that's actually doing this stuff, okay? Because that's kind of what I want to do, is basically create a line, do the thing, and have time advance, and then based on a condition if possible. So this is this example. So I'm just going to take you through my thought process in terms of stuff. And luckily, there's some good coding stuff. He basically says this example does stuff. Chuck time step is set from Unity. Depending on the mouse position, Chuck calls the Unity callback every time step. Chuck also provides a float to Unity of how far along the time step it is. This example uses Chunity helper components. Helper components. That's interesting. So there's a couple things. We get into the basic stuff for the system collections. There's no other namespaces that we're currently using so far in this particular case. We've got this other thing called the Chuck sub instance, my Chuck, and then Chuck float syncer, my advanced syncer, and then Chuck event listener, my advancer listener. So there's these three things that have to be defined here. Notice these are all private variables. They're not public variables. So here's what's interesting about this. I know enough. I've watched some videos on Chuck, and I know a little bit about how it works, and I know enough about other programming languages that I can get an idea of what this is. This isn't like completely alien to me. Like unlike Faust DSP, which is a functional language and really hard for me to understand, and C-Sound was also a little challenging. Anyway, this is a little bit much more like a JavaScript things. You get a lot of similar kinds of stuff. Now, what's happening in this particular case is they're actually sticking in the Chuck code, weirdly enough, as a string. So it's a long string that's been formatted with the @ sign in front of it. And so basically that's the idea. And then there's some kind of, looks like, quotes at the end there too. All right, so there's the float my position and the transform my cube. Okay, so that we need to have a reference to the cube and this float my position. Now the float my position gets defined there. And then if we ignore all this sort of stuff, we can sort of see what's going on with the my position. So new time step is mathf clamp, input mouse position. Here's what's basically controlling the tempo. Now, in my case, I'm not interested in doing that. I don't care about controlling the tempo with the mouse. I'm looking at the fact that what I'm doing is it's able to send a float value into Chuck so that it will then know that things need to be controlled. So that, I think, is kind of an interesting sort of situation. Like, that's basically what I'm looking for, is trying to get some input into Chuck, specifically to control the tempo. That's fine. Then after that, what I want to do is get out of Chuck a sense that it is advancing, that tempo. And then I can use that advance as a metronome effectively to drive my hyper piano row. Right, this sequencer row. Okay. Then in addition to that, there's a few other things that are going on there. But let's just take a look and see what's going on directly in Unity in terms of what's visually happening in Unity. So it says it clamps the input mouse position to all these sort of things. Then it says it's going to send my Chuck this time step, new time step. So that's the idea, is it's going to do this based on the input mouse position, which has basically been clamped into this range. So it's only going to be sending a range of values from either 250 to 1,000 essentially, and it won't change. Then this transform position equals new vector 3 my position 400, which means I guess it's rotating on the X. It's a bit odd though. Let me see what that's doing. My position equals my advancer sync. Yeah. And this is coming to Chuck here, or coming from Chuck, I should say. My position equals my advancer syncer get current value. So my advancer syncer is this thing here, Chuck float syncer. So that's the important thing. Remember, Chuck is a strongly timed language. That's the thing that was very appealing to me, because I'm going to need things to be strongly timed, My advancer listener, listen for event, my chuck, notifier, rotate my cube. Now, notifier is tricky. Notifier is been defined here. So global event notifier. This is in the chuck code, basically. And the chuck code then broadcasts that back out, notifier, broadcast. And when it is, then basically there's a listener that can be set up to listen for that broadcast. So it says my chuck, which is, I think, my instance, right? Yeah, sub instance. So the sub instance looks for the event notifier, and then it is going to call this function. The idea is that rotate my cube is going to basically rotate from current transform, new vector 3, 5, 10, 15. So it'll rotate this by 5, rotate this by 10, rotate this by 15. Here's the most important thing to talk about in terms of the input into Chuck. So my Chuck set float time step. This is how you set things inside Chuck. And this is going to be super important because, eventually I'm certainly going to want to do things like change the pitch or something like that of objects based on a row. So if I'm on a lower row, it's going to be a lower pitch, and a higher row, it'll be a higher pitch. So I'm definitely going to want to set floats for values, for pitches, and stuff like that. And then my position is, again, this is a callback from Chuck to tell Unity basically where its current position is. All right, so what I need to do is adapt this script to do what I want it to do. One thing I'm definitely going to need to do is to add to this is a Boolean. I'm going to have to add a Boolean and send that value into this Chuck script so that, so that I know that basically probably here while true, and then I would say if enabled or note enabled or something like that, then spork play note. Spork means fork off a process essentially and do a thing. Like it's a thread basically. So it's like an instance of Chuck. That's the nice thing, is that Chuck can be instanced a whole bunch, which is really very helpful. So here's a process that says play note, right? And here's a process that says update position. And here says notifier broadcast, which is a function on notifiers, I believe. Here's play note, says sign foo, blah, 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 blah. DAC, 2 second now. It doesn't say what the frequency is, so I guess it just automatically starts at a particular frequency normally. Yeah. I'll have to figure out what I'm going to do for the frequency later on. So let's make a duplicate of this script. We're going to call it whatever the heck we want to call it. And we do not need mouse updating for this, so we'll see what happens in that case. So a lot of the times when you get these kinds of packages, they're not aware of Unity's new input system. And this was a VR project that I basically set up. So therefore, the thing is that this is automatically starting with the input system. It took a little bit of finagling. It's under project settings. And I had to do a bunch of back and forth here under player settings. I think it's called input manager. Yeah. So I'm actually setting my input manager currently to input manager old. It probably should be set to both because once we actually get into VR, we're definitely going to need the new input management system. Although I have actually done a project with the VR and using the old input management system. It was, it's fine. You just add more axes. The thing with the new input manager system is that you can define one action and then you can define many different ways of doing it. Whereas the old method, you had to actually define an entry in this long database. And each entry, kind of had a particular purpose and stuff. So what happens is that if you have a situation in which you want to potentially use multiple controllers to do the same thing, let's say for multiple platforms, that's why the input system is a little bit better. I find it to be really incredibly baroque and just like, okay, this object then talks to that object, which talks to that object, which talks to that object, which makes things happen, which is a little, anyway. These examples won't work as well if the new input system is being used. And even if it's been set to both, it seems like it's a little bit ornery. And it's possible that if I set it back to both after being on the old system, it might work better, but we'll see what happens. Anyway, let's stop this. And, essentially I've got my marching orders, right? Like I know kind of what I want to do. So then the next thing will be doing it. But hopefully, I don't know if that's actually been at all in any way helpful. Um, but that's me. This is what I'm doing. I'm looking for code that I've never ever seen before and trying to figure out what it's actually doing, and more importantly, how I can then modify it so that I can do what I want to do with it. Okay. So we'll see you in the next one, and I hope this helps you get your game audio on. Take care.